Thanks everyone for joining. Thanks for taking the time today. So my name is Adi Ushstein, a VP product at Iguazio. And today I'm going to talk about, let me share my screen for a second. I'm going to talk about building an automated machine learning pipeline with Iguazio's feature store and Snowflake. Now, before we dive into the actual solution, feature store, and Snowflake, I want to talk a little bit about the MLOps pipeline and how complicated it is for customers to actually deploy machine learning models all the way in production. So a couple of challenges that we are seeing in the market. First and foremost, when customers are building machine learning pipeline, obviously there is the data scientist, and the data scientist is working on building the models, but then they also have the data engineers and the DevOps, and they need to work together in order to actually take the work that the data scientist did and apply that or deploy that in production. So there is kind of a handover between the data scientist and the data engineers in order to actually take the pieces that was developed in the development environment and deploy that in production. So in many cases, we're seeing that those guys are actually working in silos. What does it mean? It doesn't mean that they're not talking to each other. It just means that they basically work with different frameworks. So the data scientist is working with Pandas data frame, but the reality is that in production, the data engineers probably is going to work with Spark or Dust or any other framework. So there is a need to convert the code from Pandas data frame to something that is more scalable. And then in production, in general, the environment is very different than development, right? In production, you need to take care of things like testing and security and versioning and tuning and scalability and CI/CD, all those type of things that usually you don't have in development environment, or they are very, very minimal in terms of their scope in a research environment. The third part is basically everything that has to do with feature engineering. And this is our focus for today. So when you build a machine learning pipeline, obviously it all starts with the feature engineering. And when you analyze how much time it takes to actually build a machine learning pipeline, you figure out that the feature engineering part is usually the most longer part and the more complex one. So if you think about the machine learning timeline, or the time that it takes to build those pipelines, the feature engineering is a big part of it. And this is exactly where a solution like a feature store with Snowflake can be very, very handy. And then the fourth piece is all about the model and the model monitoring. And when we say model monitoring, we're basically talking about the operational aspects of the models. So you need to make sure that the model is up and running, and to analyze if there is any issue with the models in terms of latency, errors, things like that. But also in terms of drift, whether the model is actually working properly from the data perspective, or whether there is a drift. And if there is a drift, you need to obviously trigger a notification and trigger a new process to train a new model, so you can come up with a better model in your production. So those are the challenges in a very high level. And when we think about a machine learning pipeline, we have the data piece, obviously. So we have a database. In our case, we're talking about Snowflake, and Snowflake has great engines to analyze the data, to store the data, and to do what databases are doing. And then the other piece of this is an MLOps platform, where you can actually run your train the model, serve the model, create an automation out of it. And the missing piece, if you will, between the database and MLOps is the feature store. So the feature store is like an interface between the database and the MLOps platform. Because at the end of the day, when you think about the data that resides in the database, if you want to consume it by a machine learning model, you need to convert it into features. And you need to expose that in a way that the models can actually consume the data. And this is why you actually need those interface, and this is why feature store is very important. Now, the other thing that feature store provides is basically the ability to create the transformation. And the feature engineering logic in a way that can be applicable for both the training and the serving. And that's very important because in many cases, you've seen that there is a data leakage. There is a training serving skew because in your database, you are training the model under the assumptions that all the data is there in production. But the reality is that in production, in your serving layer, some of the data may be missing because it's not there in real time. And the feature store, basically solve that issue. It provides you a way to create one transformation that is applicable for both training and serving. And by doing that, you can actually eliminate any kinds of training serving skew. And there's no data leakage if you do that. The other thing that it provides you is a very, very robust catalog. So you can create features, you can search for features, you can collaborate, obviously, and you can have lots of metadata in the context of machine learning to your features. So you can see which features are related to which models, what features are more important than others, and so on and so forth. So this layer of transformation, collaboration, and eliminating the skewing, the train service skew is really important. And that's why this interface is really an important piece in this MLOps pipeline. So that's those are a couple of slides, but now let's move on to the demo. So let me share with you the my browser. So what I'm going to show you is basically an example of how you can create an end-to-end pipeline using Snowflake as the main database, and then using Iguazio feature store in order to create a feature engineering all the way to training your models and serving your model and so on and so forth. So when you log into Iguazio, this is the interface of Iguazio MLOps platform. You can see all kinds of projects. In our case, we are working on a project that is called fraud prevention. And once you drill down, you can see all the assets of the projects. So you can see the features and the data sets, the artifacts, the jobs and the workflow. All those type of things is basically part of your project. Now, if we go to the code, I'm going to show you basically how to create the project from a programmatic perspective. So we're going to see this fraud prevention demo. Basically, in this demo, I'm going to show you how you can take tables that resides in Snowflake, like transactions and events and labels. So we have 3 tables over there, and then you can ingest those tables into Iguazio's feature store. When you ingest the data, it basically goes to 2 places. It goes to a Parquet file for training, and it also goes to a very fast key value database in order to serve the features. Now, not only ingesting the data, but the idea is to enrich the data with all kinds of operations. So, for example, what we are doing here, we are adding aggregations on top of the transactions. So you can actually create sliding window aggregation on one of the columns, like amounts. The idea is basically that you can take the data from Snowflake and then add those aggregation for the serving layer and also for the training layer. And so we're taking the data, we're putting the data into the feature store, and now the data is basically ready to be consumed by the training process. So the idea here is that we can run a training process, create a model out of it, and then once the model is ready, we basically take the model and deploy that as part of a serving layer. And in the serving layer, what we're going to do is we're going to see how you can ingest or send data into the endpoint. And once the serving layer, the endpoint, is getting the request from the application, what happens is that it enriches the data using the data that we brought from Snowflake. So you have the ID. We can enrich the data with a couple of columns with the feature vector that we're basically building, and then sending the response back into the application. The last piece here is the monitoring. So once we have the model, we want to be able to monitor and see that the everything is running properly from 2 perspectives. So we have the operational perspective, which basically see that the model is actually running properly and there's no error, and things like that. And the other aspect is to see that the model doesn't have any issues with drift. I'm going into the Snowflake GUI. So in the GUI, we can see that there are 3 tables. So we have the transactions. In the transaction, we can see all the data here. So the key is the source. And then we have a couple of other features like step and age and gender. And we also have some features like categories where we did some kind of one-hot encoding in the database on the categories table. And then we have other columns like amount. This is the column that we're going to aggregate the data on, timestamp, target device. This is the target device basically, and so on and so forth. So this is one table. The other table is the events table. So in the events table, we can see the source. Again, this is the primary key, and then all kinds of changes that happen to the user, like last login, changing the password, changing the details, things like that. And then we have another table, which is the label column, label table, which basically store the source and the labels. So once we know if the transaction is fraud or not, we can actually view that in the table. So this is basically the tables that we have in Snowflake. And now the idea is to take this and ingest it into the feature store. So the first thing that I want to do is to define a project within Iguazio. We're using an open source that is called MLOps. This is the main orchestration framework that we have. So we set up the name. The name is for demo. Then we do a couple of imports. And the next step is to create those features. So I'm going to create the transaction feature set. This is how I'm doing it. I'm just creating a feature set, give it a name, the entity, which is the column. In our case, it's the source column, the timestamp, and the next step is basically to create this aggregation, this sliding window aggregation. So I want to take the amount column and I want to aggregate that by, with all kinds of operations like average, sum, count, on 2 hours, 12 hours, and 24 hours in a sliding window aggregation of 1 hour. So this is the basic transformation that I want to do. And once I define that, I want to ingest the data. So the ingestion happened by using this ingest command, and we already set up the Snowflake source with all the credentials, user, password, and all that kind of stuff. And then we are running a select star on this transaction and data set. Now, if I go to the Iguazio UI, I can see under my project the transactions in a feature set. We can see all those features, and here we go. We have those aggregations on the amount. This is basically a sliding window aggregation that is being calculated, all the time. And then we can also see all the other features that are part of it. We can preview the data. We also keep, the statistics, so we can take a look at the statistics and see that everything looks fine. And then we are also creating 2 other feature sets, the events and the labels. So we want to take the events data and the labels data. It's pretty much the same trick. We just need to create a feature set, and set up the entity, and run the ingestion command against those tables. And if I go back to the UI, I can see that those events and labels are here. We can preview the data, we can take a look at the features, and we can see that everything is looking pretty good from that perspective. So now we have the features, the feature sets. Now keep in mind that when you do the ingestion from Snowflake, what it does, it creates a feature set that goes to 2 places. It goes to the Parquet file for the training, and it also goes to a very fast key value for a very fast retrieval. So now we have a feature set for the transaction events and labels, and we can continue to the next step, which is basically creating a feature vector. So the feature vector is going to be consumed by our models in order to, first of all, to train our model, and then to serve the model in the serving layer. So the way to create those features is basically by defining the list of the features. In our case, we're taking the transactions along with the events, so all those columns that are that resides in the events feature set, joined by those columns from the transaction feature set, those comprises of this feature vector. So we create a feature vector, we give this the list of the features, and now we have a feature vector and we can start accessing the data. In order to view the data, we're just running a command that is called get offline features, and now we're getting like a data frame. So you can see here the aggregated column from the transaction feature set and also the columns from the events feature set. So those are joined together using this feature vector, and now we have a data set that is ready for training. In order to train our model, we're using one of the functions that we have here that is based on scikit-learn. So this training process is going to run and create 3 models. The idea here is that we're running a job, and the input for that job is going to be the feature vector, which is the data that we just brought from Snowflake. We also need to set up the label column, and that's it. And now we're running the training job, and we can basically look at the training job either in the UI or here in Jupyter, and we can see all the data here. So if we go to the train job, drilling down to that specific job, we also have a full-fledged experiment tracking, so you can see all the metadata about who's running the job, the code itself, the input, which is the data that we brought from Snowflake, and then it also generates all kinds of artifacts, like test data set and all the usual suspects like confusion metrics and feature importance, and obviously it's going to create a model at the end of the day. And in this case, we are also running hyperparameter processing, so you can see all the iterations and the best iteration here, and also capture the logs, and all that kind of stuff is basically being captured here. And now we have a model that is ready. So if we go to the model registry view, we can see the train model. Again, drilling down here, you can view all the metadata about the model and the job that was actually running or generating the model. We also keep track on all those artifacts that are associated with the models, the features. So you have all the information here and the statistics itself. And later on, we can use that in one of the future steps. So now we have a model. The next step is to deploy that model. So we can either deploy that from the UI, just to pick up the serving function, run deploy, and that's it. Or we can do it programmatically. So I'm going to show you how that looks like. So we have a serving function. This function comprises of 2 classes, load and predict. And what it does, it basically have an ensemble of those 3 models. And the idea here is that this function is going to get as an input the feature vector. So once the application sends the request to the function is going to enrich the data with the feature vector based on the ID, which is the key. And once we have the enriched data, and this is the data that we brought from Snowflake into the online feature store, then in real time you can enrich it and you can run the models and basically process the data and send the response back to the application. So this is how the router with these ensemble models look like. And before we deploy it, we have something that is called mock server, which is a way for us to run it locally. So we can run it here in Jupyter, we can test it out, we can see that things are actually working properly. And then if everything looks fine locally, we can deploy that function. Deploying means that we're taking the code, we're creating an endpoint with all the needed configurations. So all the environment variables, the images, the mount point, everything is basically part of the deployment. And once it's done, then we have an endpoint with this model. We can test it out again. We can invoke a request and see that the actual endpoint is working. And if we go back to the UI and we go to the model endpoints, now we can see those endpoints. We also collect statistics, operational statistics on those models, so we can see the uptime and the last prediction and latency error and stuff like that. And in addition, we also have built-in drift analysis, so we can analyze if there is any drift suspected for this endpoint. We do that because we have the ability to collect the features and the prediction in the production, and we also have the data that resides in the feature store for the training of those features, and now we can compare between those two. So if we analyze it and we see that there is a drift, we can drill down to see the individual features, and for each and every feature, we can see the actual value versus the expected value. We can run all kinds of drift algorithm like KLD and Hellinger and TVD and basically analyze what's going on there. And obviously, trigger a notification if something goes wrong. And the idea here is that at the end of the day, you want to automate this process, right? So you want to create an automated pipeline. So if we go to this workflow pipeline, in a minute I'm going to show you how to create it. At the end of the day, you're going to see a pipeline that comprises of those different steps: the feature selection, the training, the testing, the deployment. And for each and every item here, you can drill down. You can see all the metadata information. So, for instance, with this training, you can see the parameters, the start time. You can even take a look at the code itself. So you have all the information here that is basically captured using the experiments tracking that we have. And you can go here to the input, artifacts, results. If I go back here to the code, I can actually see the codes. And this is very important to be able to identify which exact code and exact data you've been using for that particular experiments. We keep hash value for this code, so if something is changing, we can always track it. Now, how do you create those pipelines? Let me show you how you can actually do that. So we have a project. In that project, we have those functions that are doing the ingestion, the training, using the scikit-learn, testing, deployment. And what we need to do is basically to create a workflow file. So this is the typical Kubeflow pipeline DSL. Under the hood, we're using Kubeflow in order to run those pipelines. So this is how it looks like. You have those different steps. For each step, we have the function that is running the step. This is the same function that we've seen earlier. So we have feature selection, and training, and testing, and deployment. And essentially, what you want to do is to register that workflow, to save it as part of your project. And now it's going to go into the project YAML, and then run the project, run the workflow within the project. And that's going to create this pipeline that comprises of those different steps. And then you can schedule it and you can re-trigger it. So if you go back to the drift that I was talking about, once you identify that there is a drift, you can actually re-trigger this entire pipeline automatically. So you can create a new model. You can compare between the different runs of the models and then deploy that model in your serving environment. So see that time is running, and so that was pretty much the demo that I wanted to show to you. Hope you enjoy that. Feel free to go to our website, iguazio.com, MLOps. We have lots of materials, lots of blogs and videos about MLOps in general, and specifically about Feature Store and our integration with Snowflake. So you're more than welcome to go over there, and we'll be more than happy to be in touch with you. Okay, so thanks everyone. Hope you enjoyed it, and bye for now.